Okay, for every single problem that you do, you need to make sure that your function's factored fully, and this function's denominator needs to be factored. So I'm going to go ahead and do that. I'm going to take out a greatest common factor in the denominator of x, and then I'm left with x plus 3. And then I see that I have a common factor in my numerator and denominator, the common factor of x, and that set of x's are going to cancel out. That's where your whole is going to be. Anytime you cancel out common factors, those factors determine your wholes. So technically x divided by x isn't 0, you just don't wipe it out. Technically x divided by x is 1. And when you rewrite your function with that factor canceled out, I need to put the 1 in the numerator. If I had other factors left or other things left in the numerator, I wouldn't need to write that 1 in. So this is now my modified function, and I'm going to use that for most of the rest of the problem. There's still a couple things that I like to use the original function for, but I'm going to use this for most of my work. Okay, so first of all, I'm going to find that whole. I'm going to take my factor that I canceled out, which was x, and I'm going to set it equal to 0. And then I'm going to solve it. Well, there's really nothing to solve here. It's already solved, so my whole is at x equals 0. But I still need to find the y-coordinate of the whole. I only really have the x-coordinate where the whole is. So I'm going to take that 0, and I'm going to substitute it back in to my modified function. So I have a whole at an x of 0 and a y of 1/3. And once again, you're not going to substitute that x value back into the original. You're going to substitute it into the modified. Now we're going to find our vertical asymptotes, and I'm looking at the modified function that we changed. And vertical asymptotes are found at undefined points. And undefined points are found by taking your denominator and setting it equal to 0. And my denominator is x plus 3. So I'm going to take that x plus 3 and I'm going to set it equal to 0. And then I'm going to solve it. And that is going to be the vertical line where your asymptote is, written as x equal -3. Now we're going to find a horizontal asymptote, and a horizontal asymptote compares the degree of your numerator with the degree of the denominator. The degree of the numerator is a degree of 1. The degree of the denominator is a degree of 2. The numerator's degree is less than the denominator's degree, and every single time your numerator's degree is less than the denominator's degree, you have a horizontal asymptote at y equals 0, which is also the x-axis. Now, when you compare the degrees, you're looking at the first term in each polynomial. The first term is what determines the degree. So when I want to know the degree of the numerator, I look at the degree of the first term, and when I want to know the degree of the denominator, I look at the degree of the first term, and it's the exponent that you're looking at. The next thing that you're going to find are the zeros of the function, which are the x-intercepts. And when you want to find your x-intercepts, you're looking for what makes the numerator equal to 0. And I'm going to be working off my modified function's numerator. So I'm going to take 1 in and set it equal to 0. My numerator is just a 1, and I set it equal to 0, and that just makes a false statement or a false equation. So I don't have any x-intercepts or zeros. So we just write none. The y-intercept is when your x is equal to 0, but this problem's kind of interesting because I have a hole at x equals 0. If you look way back up here, my hole is at x equals 0. So I can't really plug in a 0 into my problem. So I don't have a y-intercept. I can't let x equal 0. There's a hole at x equals 0. And then finally, I don't have a slant asymptote. A slant asymptote is when your numerator's degree is 1 bigger than the denominator. I already have a horizontal asymptote, so I don't even need to bother looking at a slant. Now, all of these things that you just found in this list are going to help you graph. After you get all of these things in place, then you're going to figure out a couple extra points depending on what your graph looks like after you put all these things into place. So let's just start by putting in the asymptotes. I have a vertical at x equal -3. So I'm counting back 3 on the x-axis, and then I'm going to put a vertical line right in there. And then I also have a horizontal asymptote right on the x-axis. Which is y equals 0. Okay, so I did my vertical asymptote and my horizontal asymptote. I don't have any zeros, so I have none of those to graph. I don't have a y-intercept because I have a hole there. The only thing I haven't graphed yet is the actual hole, and the hole is at 0, 1/3. So at 0 up 1/3, and I'm going to go above 1/3 so you can actually see the hole. At 0, 1/3, there's a point with an open circle. Now I already know what the rest of my graph is going to look like just based on the fact that I have my hole up at 0, 1/3. My graph's going to be up in this quadrant right here. I don't have any zeros. I have no x-intercepts, no other points that cross the x-axis. So my graph is going to come down from the hole along that asymptote. Now I know that's pretty squiggly. I can try to redo it, but I'm in an awkward position right now. Not at a table trying to do this. So anyway, just pretend that's a pretty straight looking line there, or curve, a smooth curve. That asymptote's going to hug that curve's going to hug the asymptote right there and not cross over the x-axis. I would need an x-intercept for my graph to go like down. I don't have any. Also, as my graph comes back to the left, it's going to move upward and hug that vertical asymptote because you can never, ever, 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 ever cross a vertical asymptote. And I know my graph isn't going to like swing down because I don't have any more x-intercepts for my graph to cross through. Now most likely my other part of my graph is going to be in the lower left portion here, in between my horizontal and vertical asymptote right here in this section where my cursor is moving. But just to verify, let's go ahead and get a point down there. And you can use your modified function to pick another ordered pair. So I'm going to use the 1 over x plus 3. So I'm going to let x equal -4. And I'm going to put that over here because I don't really have any room. So then I get 1 over -4 plus 3, which is 1 over -1, which is -1. So when we're at -4, we're down at when we're over at -4, we are down -1, and my suspicions are correct. And once again, I don't have any intercepts on the x-axis. So as my graph moves to the left, it's not going to like swing up because I can't cross the x-axis. I don't have any more intercepts. So most likely it's just going to go ahead and hug that horizontal asymptote. And also, I know my graph's not going to like swing over that way because I can't ever cross a vertical asymptote. I know my graph, as it moves closer to that vertical asymptote, it's going to move downward and hug right against that asymptote. And if you just want to verify that, go ahead and find a couple more points. Maybe do -3.5 right there. Maybe do -5 right here, or maybe -6 right there to actually see what your graph's doing. You can plug a couple extra points in if you want to. I'll give you one more. I'll give you 48. So 48 looks like we have to factor the numerator and the denominator. Every single time you do a problem, you're going to factor your numerator and your denominator fully. And if anything cancels out, it's a whole. So I have x and x, and a 2 and a 1 on the top, and the 2 has to be negative, the 1 has to be positive. On the bottom, I have x and x, and factors of -6 that add to -5. Looks like it's going to be a 6 and a 1, and -6 and +1. And we have a factor that cancels out, which means there's going to be a hole there. And my new modified function, I'm going to write it down at the bottom. My new modified function that I'll be working off of is going to be x minus 2 over x minus 6. And you can use that for every single part of the rest of the problem if you want to, even though when I find the y-intercept, usually I just look off the original. If there happens to be a lot of factors left over in the problem, like there's more than just a single factor on the top and bottom, I usually like to look back at the original for the y-intercept and comparing my degrees of the numerator and denominator, but you can work off this new modified function for the rest of the problem if you want to. Okay, so I know I have a hole where this factor is equal to 0, and if I take x plus 1 and I set it equal to 0, I guess I'll just do it. I wasn't gonna, but I changed my mind. So I have x plus 1, set it equal to 0, I get x equal -1. That's just the x coordinate of the hole. Now you have to find the y coordinate. So we're going to find f of -1 on the modified function, which is -1 minus 2 over -1 minus 6. We have -3 over -7, which is 3/7. If this were 3 over 6, we'd have a half. So 3 over 7 means I have a little bit less than a half, like 0.4 something. When I graph it, it'll probably look like -1/2. Just, you know, because my blocks are small and it's hard to estimate 0.4 very good on this graph paper right here. Okay, so let's go ahead and do our vertical asymptote. Now that we have our hole, our vertical asymptote, looking off the modified function, our vertical asymptote is where our denominator is equal to 0. It's the undefined point. So I take x minus 6, set it equal to 0, I get x equals 6. Now we're looking for a horizontal asymptote, and I'm looking at my degrees of my numerator and denominator. They're the same. I have an x squared over an x squared. So your horizontal asymptote is going to be the coefficient of the numerator over the coefficient of the denominator. It's actually going to be y equals the coefficient of the numerator over the denominator, and you get y is equal to 1. Then we have our zeros. You're going to take your numerator and you're going to set that equal to 0. Find your x-intercepts, you figure out what makes your numerator equal to 0. And so I have a x-intercept at 2, 0. It's where y equals 0. You don't write x equal 2 up here because that would be a vertical line. You just want an ordered pair, an x-intercept where y is 0. Okay, y-intercept is where your x equals 0, and I can plug into the original or sub into the modified, whichever's easier. I'm just going to, this time, plug into the modified an x equal to 0. Usually I go off the original for my y-intercept, but I'm going to go off the modified. So if I plug in a 0 in for x, I get -2 over -6, which is a third. So when x is 0, my y-intercept is up a third. And finally, here we have no slant. If you have a horizontal, you're definitely not going to have a slant. A slant asymptote is when your numerator is exactly 1 degree more than your denominator. So now we're ready to graph. I'm going to put my vertical asymptote in first. Hopefully I'm counting right. It's supposed to be over 6. Pretty sure I'm over 6. And then I have a horizontal asymptote at y equal 1. So now we're going to be not on the x-axis, but up at 1. I have a 0 at 2, 0, so over 2, up nothing, or right there. I have a y-intercept at 0, 1/3. I have a hole at -1.4-ish. So -1.4-ish. There's a hole. And I've got nothing else to graph. So the only thing that I can do from this point on is find a couple extra points. So I'm just going to go ahead and substitute into my modified function. I just don't have a lot of room. I don't even know where to show this work. So typically I'll just use my graphing calculator to get the ordered pairs. Alright. Okay, guess what? I am going to use a graphing calculator to find my ordered pairs because this isn't cooperating with me. So I'm putting in my modified function, but normally I just put in the original function. And then I'm just going to look at the table. And so you can see when we are at 0, we're up a third. And when we're at 2, we're at 0. So some of those ordered pairs are verified. That's where my hole is, even though the graphing calculator isn't going to pick up the hole. So let's do, I don't know, negative, or not negative, let's do 5. So when our x is 5, we're at -3. Hopefully this cooperates with me and I can actually draw on it. When we're over 5, we're down 1, 2, 3. And notice at 6, there's an error, and it should be there because that's where our asymptote is. cannot use a 6 to plug into this function because it makes your denominator undefined. So we'll take 7 and 8. At 7 and 8, you have 5 and 3. So over 7, you're up 1, 2, 3, 4, 5. When you're over 7, 1, 2, 3, 4, 5. And then at 8, you're up 1, 2, 3. And that's good enough. I don't even feel like clicking over to my calculator to look at another point. So I could actually cross this horizontal asymptote. I might cross, but I don't care enough to check. If you are going to cross a horizontal asymptote, it's probably not going to like swing up like that. It's going to probably hug that asymptote. Not that it couldn't look like an x cubed, but and then as we come over this way, it's going to definitely hug this asymptote right here, because you can never cross a vertical. If you want to know whether or not your graph's going to like shoot up crazy or something, if you feel like you need an extra point, go ahead and look at the graph or verify with the table. When I move out to like negative, I don't know, 10, I'm still at 0.75. So back 10, I'm up 0.75. So you're definitely not doing anything but hugging that asymptote. And then over here on the right side, I won't be crossing this vertical asymptote. I won't be crossing this vertical asymptote. I can't even draw it in. Because you never cross a vertical. Alright, I just can't take this anymore. I'm not going to like redo that, but just pretend I connected the dots nicely. I'm afraid to lift my pen. So you never cross a vertical asymptote, and as I come down, I know I'm going to be hugging this asymptote or just crossing maybe by a little bit. Because I don't have any more x-intercepts, I'm not going to be like crossing over and moving downward. Otherwise, I'd have another x-intercept over there. And again, you can just find, if you want to, a couple more points to verify that you're on the right track with your graph. Just the fact that I don't have any more zeros, I don't have any more x-intercepts, it's really a good guide to tell you what your graph's going to look like. You can never, ever, ever cross a vertical asymptote, and you sometimes might cross a horizontal asymptote. But knowing that I don't have any more intercepts just kind of tells me that this current graph is going to just hug the y=1 asymptote, and I'm not going to be like moving down over the x-axis.